Welcome to the OSDU Data Platform Application Development Training. In this video, I will provide an overview of the OSDU Data Platform. Now to the topics that will be covered by this video. We will start with the reference material. This way you can stop the video anytime you want to and go look at additional information for more detail. We'll then go into the OSDU Forum goals, discuss some of the initial technology development goals, move into the reference architecture covering principles, information architecture, functional architecture, services architecture, and data flow. And finally, we'll close with an introduction to the community development that's building the data platform. Now let's look at some of the reference material that's been developed to support the OSDU data platform. The OSDU Forum has developed or is in the process of developing quite a bit of documentation around the OSDU data platform. Some of the documentation includes the system concepts, which describes why the platform was built and what it's intended to do. The reference architecture document, which provides a great deal more detail than what you're going to see in this presentation. The schema usage guide, which discusses the information model for the OSDU data platform. It's quite useful in terms of being able to understand the sort of content you're going to get back in the metadata. The testing guide, API and test cases, is a comprehensive list of all the APIs and all the methods for calling them. It also provides the expected returns out there. It's a very useful piece of documentation, and I recommend everybody use it as a reference. The location for finding the documentation is at the osduforum.org, getting started, OSDU documentation. And I will provide a video going through the actual website next. Let's take a look at some of the documentation that the OSDU Forum has developed. If you go to the OSDU Forum's website at osduforum.org, you'll see a menu across the top. One of them is the application development, which is useful about learning how to develop applications and get them registered by the OSDU Forum. But to find the documentation, let's go to Getting Started. If you go to Getting Started, go down to the bottom, you'll find Documents and Tools. Navigating to this site gives you access to all the documentation that has been published or is in development in the OSDU Forum. If you scroll down, you'll see that it is arranged by various roles. Some of the most important documentation to look at is under Platform Provider, the system concepts, which gives you an introduction to the reason, rationales, and purpose of the OSDU data platform. If you go down to the application developer, additional useful documentation is the reference architecture, which talks about how the system is built in more detail. The schema usage guide, which gives you a lot of insight into the information model. The testing guidelines, API and services test cases. This gives you a comprehensive view into all the APIs themselves and how they're called and what the expected responses are going to be. If you're looking at loading data into the system without writing a program to do it, you can take a look at the generic DAG onboarding, OpenVDS, the data loading guide, and the ingestion workflow using the CSV DAGs. And finally, there is a version of the application developer guide on the website. However, this is currently for R2. It's still relevant, but doesn't include all the services that are available in R3. To summarize the documentation, we have the systems concepts that provides the overview of what the platform is intended to do, the reference architecture that describes how it's built. The technical standards are the actual standards that are being developed by the open group, OSDU Forum, which will guide the definition of what a proper OSDU data platform is. There's the schema usage guide, which gives you insight into the metadata, the application developer guide, and a bunch of other documentation that's out there. One thing that's important to recognize is that some of this documentation has been published, some of it's under development. If it's currently under development, it's only available in the members GitLab, which means you have to be a member and have credentials in order to be able to get access to it. Beyond the documentation that was discussed earlier, another useful source of information is where the code is being developed for the data platform itself. It's in a community GitLab. There are two GitLabs within the OSDU forum. One of them is the members GitLab, which requires you to be a member to get the credentials to access it. The other one is the community GitLab, which anybody can get access to without credentials, without registration, if you want to. Within the community GitLab, you'll find all the code for the data platform, the system services, the data services, the domain management services, validation test cases, and etc. The location for the community GitLab is at community.opengroup.org/OSDU, and I will provide a video for navigating it next. All of the data platform code is located in the community GitLab under an Apache 2 license. You can find it at community.opengroup.org/OSDU. Coming into GitLab, what you see is sort of a high-level directory structure or folder structure. The key projects and folders are documentation. If you go into documentation, you go to the wiki, you go to platform and components, and you scroll down and go to the core services catalog. What you see is a nice table with a list of all the services, the API specifications, and documentation on how to use the APIs. And if you're interested in looking at the code, you can take a look at the code repository itself, and this will take you to the individual microservices so you can take a look at how they're built. Right. Going back up. Another useful folder area is tutorials. These are tutorials that were developed for R2 and are still relevant for R3, although there are obviously additional APIs and services in R3. If you're really interested in the data platform itself, you can go to the platform folder, platform group, and you take a look at all the services and how they're built. Some of the very interesting services or important services are under the system structure, which are the core services of the platform, and I'll go through one of them and show you how it's laid out. An example is the storage platform. If you go into storage, you take a look at the repository. You can see the layout is as follows. There is common code, which is code that works on every single cloud provider, and you can go through and take a look at all the code itself. It has source code. In this case, it's all in Java. There are unit tests associated with each of the services, and you can see the structure or the content of this particular microservice. One important area is the provider interfaces. These are interfaces that are defined so that anybody can implement it on additional cloud platforms. Going back up the hierarchy, what you can see is that there is a provider folder as well. Under the provider folder, you can see the different implementations that are available. There's one on Amazon, one on Microsoft, one on Google, one on IBM, and MongoDB has an implementation of the storage service as well. And again, going back up to the top, if you take a look at the docs folder, you'll see the API specifications. You can go through it. This is a way of navigating to the APIs from within the source code itself, rather than using the wiki. Right. And if you want to take a look at how to use this particular service, you can go to the storage service documentation itself, and it provides a brief tutorial on how to use it. Anyway, this is a very brief introduction to the community GitLab. I recommend that everybody spend a little bit of time navigating through it. There's a lot of useful information in the community GitLab. However, there is so much information that it sometimes takes a while to learn how to navigate through it. In addition to the documentation and the source code itself, another very useful piece of reference for application developers is the integration test and workflow tests that are developed by reading the documentation. You can find this in the community GitLab by going to the platform validation project, which is under the OSDU platform group. Inside of it, if you go to the repository and you get into the Postman collections, what you'll find is the Postman collections that have all the test cases for all the services that are in the OSDU Data Platform. So you download these things, take a look at them, and they're a very useful reference for how to call the various services and what the expected returns are going to be. Well, that's all I'm going to show on the reference material. My recommendation is that everybody spend a little bit of time and go through it, browse through it, because it's going to be a critical source of information for the future. The next section I'm going to talk about is the OSDU Forum goals. Why are they building the data platform? It's important to understand these goals because they'll give you insight into the direction in which the platform will be developed in the future. This is the OSDU mission statement. It reads as follows. The Open Group OSDU Forum delivers an open source, standards-based, technology-agnostic data platform for the energy industry that stimulates innovation, industrializes data management, and reduces time to market for new solutions. Within this mission statement, there are some key phrases. The first one is that it is open source. It's developed under an Apache 2 license and an open GitLab allows people to contribute based upon their particular interest. This means if somebody comes to the forum, finds that the platform itself does not deliver what they want, they have the freedom, ability, and even obligation to contribute themselves. This provides a great deal of agility in the platform. In addition to being agile, it's also standards-based. The purpose of the standards is to ensure that it's interoperable across multiple cloud providers and to assure that it's future-proof. As people adopt the platform today, they are guaranteed that they have an evolutionary path to the future. It is technology agnostic. The platform itself is designed around the concept of common code, which captures the behavior of the system that works across all the cloud providers, as well as technology-specific or cloud platform-specific technologies that's optimized for each particular cloud platform or even on premises. It is a data platform. It's not simply a storage solution or a data management application that has a very fixed purpose. It is a modern cloud-native data platform based upon a microservices architecture that allows it to evolve in the future. The intention of the platform is to evolve to capture new behavior required by applications and support new data required by operators. And it is developed for the industry and is opinionated around the things that are concerning to this industry, such as regulatory requirements and the massive amounts of data that are acquired over time. It started in subsurface oil and gas. It moved rapidly into the area of upstream, and it is following the evolution of the industry into new energy sources. This is a more recent statement of the OSDU Data Platform goals. The message behind the statement is the platform's goals to balance flexibility with usability. The platform has a set of generic APIs that allow you to add new data types without adding code into the system. It's very easy to register new schemas, bring in new parsers, and be able to find, discover, and download data without adding a lot of code. But at the same time, this flexibility is not necessarily usable for applications. Applications prefer type-safe, optimized APIs for data access. Without these optimized APIs, applications will typically use a data platform simply for storage and download the data and operate outside of it. So the OSDU Data Platform provides a combination of generic APIs, which gives flexibility, and domain APIs, which provides optimization and usability for applications. Right? And you'll see in the architecture how these competing goals are addressed. The implementation of the OSDU Data Platform did not begin in the OSDU Forum itself. largely started from code contributed by Shell and Schlumberger. And the following slides talk about the original development goals because it gives insight into how the architecture itself was developed and has evolved. The original purpose for the technology development around the OSDU Data Platform, or certainly in the code that was contributed to the OSDU Data Platform, was to break down barriers by making information discoverable, available, and usable across domain and functional silos. It was not developed specifically in the space of subsurface measurements. It was actually developed to address the needs of upstream companies. Right, its scope, upstream oil and gas, moving everywhere from exploration into production. And it was not simply focused on the measurement side of it. Again, it was also looking at breaking down some of the functional silos that exist in our organizations, certainly around the functional disconnect between planning operations and actually performing the operations. From a maturity point of view, the code development started in 2015 on the Google Cloud Platform. It was commercially available inside of Schlumberger's Delphi, and it was contributed to the OSDU Forum in 2019 to be aligned with the code that Shell had contributed prior to that. It's aligned to the OSDU Forum goals, Shell's initial contribution, other members' contributions. So it's not simply a copy of the code that came from Schlumberger. It has evolved since then to meet OSDU Forum needs. It's been ported to additional cloud platforms by Amazon, Microsoft, and IBM, and there are pure open source implementations currently under development. And the model of development is based around this notion of DevOps. So it's intended to be evergreen with continuous addition and improvement through continuous delivery. So there are no big bang releases of the OSDU Data Platform anymore. The intention is to continue to continuously develop new functionality and deploy it to the community. This is going to be a significant change in terms of the ways that people adopt technology in the past. So one of the original statements that that drove the development of the platform is that it was intended to support an integrated approach, breaking down barriers among vertical silos, between planning and operations, between operators and suppliers, and past and future knowledge. So this was a mission statement from 2015 that persists today. This is the initial data footprint that was driving the development of the data platform as contributed to OSDU Forum. As you can see, it covers everything from seismic acquisition, which happens every few years, down into production operations where data comes in every few seconds. It carries a lot of workflow information, so the movement of information from one operation, one process to another process, and intended to also make sure that this information can be consumed backwards into these processes or business processes so that we can have a continuously updated model of what's going on in energy. And not only is it focused on sort of the measurements, models, interpretations, and everything else coming from the field, but it also recognizes a lot of this information. A lot of business is operating in the context of the competencies of our people, geopolitical conditions, and frankly, even taking into account how equipment and manufacturing behave in certain environments. So it's a very comprehensive data model. The intention is to make sure that we focus on the union of the content rather than simply the intersection of this content that we've seen in the past. Now that we've seen some of the goals for the OSDU Data Platform and some of the specific goals that drove the implementation of the technology that was contributed to it, it's time to get into the reference architecture. This is a fairly simplistic view of the OSDU Data Platform. Moving from bottom up, what we'll see is that we have cloud-specific code. So there are implementations that are optimized for various cloud providers. And to ensure portability, what we have is this idea of, or this notion of a service provider interface on top of it. So basically the SPI is an API to various clouds, and it isolates the platform's common behavior from how it's deployed and implemented on various cloud providers. By providing this SPI, what we allow is each of the cloud providers to optimize for its particular infrastructure, which has benefits in performance and economics. On top of the SPI, we have the OSDU Data Platform core code. This is the technology agnostic and the data agnostic code in the platform. So this is where all the core microservices are. Right? All these microservices are exposed through APIs, and on top of these APIs, we have implementations that are optimized for various domains. So you'll see later on that we have this notion of the domain management systems, data management systems for various domains to give the application developers optimized access to specific data types, or applications can come through the generic platform APIs and get access to content that's been registered and stored in the platform itself. So this combination of highly flexible access and data platform and highly optimized access for specific data types is sort of this notion of flexibility and usability built into the same data platform. And on top of this, we have all the applications themselves. And you'll see one of the common themes is that nobody gets access to underlying technology directly. Everybody goes through APIs to get access to any of the services that are inside the system. Right? Everything in this area here is developed in the community GitLab under an open source model, right? And is available to anybody to download and contribute themselves. From a deployment point of view, people can download the code themselves. They can get access to the platform through a PaaS model by cloud provider or a SaaS model provided by software providers. The OSDU Data Platform can be deployed in a variety of different ways. One of the deployment models is the multi-partition model or multi-tenant model. And this provides an organization to build hard partitions, isolation boundaries between data from different organizations, whether these organizations are internal organizations between departments or external organizations such as you would see between different customers. Another deployment models is multi-region, right, where we have different OSDU instances available across the globe. And what happens in the system is that metadata can be synchronized between the various instances, and content, the actual data content itself, will be pulled or maintained in a home instance. So this allows metadata to be shared for efficient discovery without having to move the content itself. There's also a notion of an external data source where data can come from an external provider. Again, metadata is synchronized between the external data source and an OSDU instance, and content is maintained offsite. Some of the sort of the key differences between multi-region and external data sources. In multi-region, all of these instances are true functional OSDU data platforms, which means data is managed in a consistent way. Each of these instances honors all of the obligations of a data platform. An external data source does not do so, right? What it does is it simply supports the discovery and access of external content, but that content itself is not managed by an OSDU instance. Right. The OSDU data platform is built upon a number of principles. These principles both cover data as well as the system development itself. Principles are quite important in any architecture development. What they do is they ensure long-term and consistent behavior across the platform. The first sort of meta principle is this notion of aligned autonomy, right? As mentioned before, we have the OSDU Data Platform developed under a combination of open source and open standards models. So the open source provides a great deal autonomy. It allows the community to contribute and to the data platform and move it in directions very rapidly that meet the end user's needs. Right. However, if we didn't have some mechanism to ensure alignment, what would happen is we could end up in a situation where the platform itself evolves in directions that are somewhat unpredictable and chaotic. Right. So the idea of the open standards process is to make sure that what we have is we have sort of a deliberate approach in the direction that the platform evolves to ensure there's consistency in that evolution itself. So in the direction in which it goes, and also in the standards under which it is developed. All right. Along the same line, you can apply that to how the system itself is built. There's this notion of intentional architecture and emergent design. There is a reference architecture for the OSDU Data Platform. It describes a desired future state, and the implementation itself has to adhere towards the direction of this architecture. However, it's not extremely specific in terms of the implementation detailed design decisions. These design decisions are developed as the platform is being built and based upon use cases. This avoids speculative development and makes sure that the platform itself, while aligned towards a common future goal, evolves based upon real-world needs. Most of the principles of the OSDU Data Platform were put in place prior to the initial implementation of the code in 2015. However, with the contribution to the OSDU Forum and the release of the Mercury release, we've taken some time to step back and take a look at which principles may need to be revisited and whether we needed to introduce additional principles as well. So I'll go through the principles for the system development here. So the first one was taking a user-centric approach. And this is very much aligned with the intentional architecture emergent design, which states that you should wait until you actually have a use case that you want to implement before you do the implementation itself. And so you're driven by real-world needs and get real-world feedback. The second one is microservices architecture. So the system itself is pure microservices. Every service that's out there is developed independently and can be deployed independently. Right. This allows us to support autonomous teams, since each of the microservices are somewhat independent, or very independent. From a development point of view, we can put teams around these microservices that can evolve them over time. So the architecture itself and the principles itself bring the alignment, but the microservices brings the autonomy. Right? And then this notion of continuous delivery and continuous feedback. Right? This is not big bang releases. They do a lot of speculative development and push it out to the marketplace. The idea is to be able to continuously develop, continuous delivery, and continuously deploy the platform itself, and to look at the feedback. This way we optimize based upon consumption. A next sort of area of system design principles is around security. All right, make security everyone's concern. So because this is continuous deployment, continuous delivery, cloud-based architecture, there is a shared responsibility around security, so it needs to be considered from the time of the requirements of the system through the development, through the deployment, and into the operations side of it. So everybody's involved in security. Leveraging cloud provider expertise. That's right, this drives the notion of defense in depth, or layered defense. The OSDU Data Platform itself has a fair amount of security built into it. But when possible, it delegates security down to the cloud provider itself to provide the deepest level of security in the platform. Protect data as the most valuable asset. So you can see in a number of the services and the deployments and implementation that data is the asset of the system, not the services. So the data itself is granted a great deal of protection, both in terms of access control and even in the areas of business continuity. Right? And in this area of security and entitlement, putting the platform operator in control of data and users, the intention here is to kind of avoid the Uber owner scenario where there's one administrator that has extremely elevated privileges to access everyone by putting the burden down to the operator in terms of controlling access to data and users. This allows the operator, the owner of the platform, to control all these things. There is an area around DevOps itself. So monitoring and support is important for the platform. This is a platform. It's intended to be deployed in an enterprise environment. It's expected to have multiple nines of reliability, which means that you have to be monitoring it constantly to determine whether it's performing properly. The DevOps delivery infrastructure, again, it's continuous delivery, continuous deployment is actually a goal someday, right? In order to do that, you need to make sure that your delivery infrastructure is robust, reliable, and repeatable. And along the same line of robustness and reliability, again, if we're going to have multiple nines of uptime, then you need to be looking at very robust and fault-tolerant patterns, including service replication or rollback capabilities. While there's a great deal of autonomy allowed in the system, at the end of the day, it's got to be developed and supported by community. So we want to make sure that we kind of standardize or select a relatively few number of technologies, languages, frameworks, and protocols, etc., because this improves the reliability of the overall system, and also it improves the ability to migrate developers from one service to another if they're all built roughly the same way. And then the last one in DevOps is the automation at every step of the way is key. There is this notion that anytime there is human interaction and something that is repeatable, it's considered a defect. If you really want consistent behavior and consistent flow in terms of the development, you really need to be focusing on automation. And then the last area is the multi-cloud side of it. So there's two ways of doing multi-cloud. So one of them is being technology agnostic. The other one is to be technology portable. And the OSDU Data Platform has chosen the OSDU portable side. It recognizes that the data requirements in oil and gas and energy segment itself is quite demanding. You really need to have usable performance at reasonable cost. In order to do this, you need to be able to leverage cloud technologies as much as possible. Right? And the next portion is, managing, leveraging these cloud native managed solutions where possible. Not only does it give you the performance and economics, but frankly, it also gives you the operational simplicity. These PaaS services are often much easier to monitor and to operate than trying to load something in infrastructure and manage it yourself. But the complication associated with being cloud optimized means that you end up with a diversity of solutions, and this is why we've introduced this notion of SPIs, service provider interfaces, that separate the common behavior of the code, the common code in the system, from the cloud implementation itself. Right, and this gets into the next part, which is this clear separation between the common code and the cloud functionality. All right. And then the last portion of this kind of follow on to the previous ones, which meant that if the CSVs are providing functions, they need to be behaviorally symmetric, right? If we're going to be providing the same OSDU behavior across multiple cloud platforms, then we need to choose the technologies at the CSP that provide the functional symmetry that we need. Since the OSDU Data Platform is, in fact, a data platform, it's quite appropriate to have data principles. And in fact, the data principles themselves define the behavior of the data platform more than the system principles, which pretty much define how it's built. The first category of the data principles is the fact that the platform itself values all data, right? Really, it's a hungry system. It wants to simplify the ability to collect and make data discoverable for other parties out there. In order to do that, it needs to minimize the friction on the receipt of data. There are a lot of data platforms that exist that focus on high quality schema specific data coming into the system And in fact, they reject all data that does not conform to the quality and representation requirements. The OSDU Data Platform is the opposite. Really, it allows you to define new data types easily and simplifies the ability to bring them in. And in fact, there are really only two obligations for bringing data in the system. The first is that it is described in a way that it can be discovered and used in the future. And the second one is that there's a notion of governance and entitlements, which ensures that you have the right to use, you understand your right to use the data in the future, right? The second value all data principle is that data content and context as received in the data platform are preserved, right? What you don't want to do is you don't want to lose any of the information that you already have. So you bring the data in from external systems. You want to preserve as much as possible instead of throwing out content that you don't know how to use at the moment, because you might know how to use it in the future. And then the third one is that the data in the data platform is treated as immutable. Right? There is a notion of enrichment in the platform where you improve data once it's inside of the system, but to be able to preserve the lineage of the data inside the system, to preserve the explainability of it, you need to make sure that you don't update it in place. So creating new data is actually creating new data. Right. The next category is using data securely and responsibly. So all the data in the system is access controlled. The owner of the data, the operator, defines which organizations and which users get access to it, and the data platform itself ensures that. The data is governed for right of use. Within the industry, there's more than simply data entitlement that describes whether somebody has access to it. There are a number of regulatory or corporate policies as well. So there is a policy-driven access supported with that in the system. And then the third one is, data is not owned by some super administrator. Data is owned by the DP operator, or data platform operator themselves. And this way, they're the ones that grant access to it and define the policies for accessing it. Right, and so this honors the least privileged principle for security. The next big category is this notion of minimal viable governance. Again, bringing data in the system, we want to make sure that it's discoverable and that it is entitled, that we understand our right of use, and that's what these principles are involved in. So one of them is, data is globally identifiable across data platform instances. I spoke earlier about the different topologies associated with the data platform deployment. They can be deployed in as multiple partitions. They can be deployed in multiple regions, and you can have external data sources. And in order to be able to manage this data globally, they need to be uniquely identifiable across all these implementations. The data itself is classified. This is an element of being described. You understand what type of data it is, and there may be different business rules associated with the classification of data that are implemented later. Data is discovered, which means the data has to be described in a way that it can be searched, and then the data has to be consumable. And then the fourth major category of data principles is this establishment and continuously improvement of data in the system. So the data platform itself is very much schema on consumption. There's this notion of bringing in data with relatively low friction, which is part of the value of data. But we really want to make sure that data is consumable for the workflows in which it's needed, which means that we need to be able to improve the data in ways that make it usable for those things. And that improvement can be in terms of representation, it can be in terms of quality, it can be in terms of access patterns and performance and out there. So one of the categories here, one of the recent ones that was added with the Mercury release is this separation between the generic APIs and the DDMSs. So data can be accessed either way, either generically as it has been brought into the system, or it can be accessed through these optimized APIs which provide usability for applications. Right? Honoring the principle of immutability, it means that any of the data that's been improved inside the system is treated as new data, both in terms of the content of the data itself and the context in which it's done. So you can improve the metadata, you can improve the data itself. And of course, if you are improving the data in the system, then you need to maintain this idea of versioning, new versions of the data, so you don't overwrite the original stuff. Or it can be a derivative of the data, in which case you need to track the lineage, the data from which it is derived from. Anyway, so these are the data principles of the system, and they map pretty much directly to the implementation of the features that are inside of it. I'm now going to talk a little bit about the information architecture for the OSDU Data Platform. There are three major categories of data that's inside of the OSDU Data Platform. The first one we refer to as content data. And this is data that would exist whether or not there was an OSDU data platform at all. So this can be things like field measurements, they can be things like interpretations, they can be things like models. Effectively, these are data that exist outside the platform as well as inside of the platform. Right? The second major category is what we refer to as the resource data, or often we refer to this also as metadata and policies. So the resource data is really the thing that is produced and managed by the data platform, and its purpose is managing and classifying the content data. So the resource data, the metadata, is frequently quite rich. It's used for search and discovery. It's used for describing entitlements and access controls inside the system. And frankly, a lot of the initial interactions with the data platform is not around the content data itself, but around the resource data as people search through and find the information that they want access to. And then the last category of data inside the system is the systems data itself. And so this is really the data that's produced for managing and understanding the behavior of the data platform itself. So things like configuration of the services, setting up security around system security policies, not around the data itself, but around APIs, managing the behavior of the platform itself, configuring it for multi-tenancy, multi-partitions, multi-region support, registering external data sources. And it's also the logs that are produced by the data platform that provide both kind of health awareness, is the system performing the way it's supposed to, as well as logs for auditing purposes. Are people getting access to the information that they want securely, and who has access to the information, so that we can always go back in time to figure out where the information is proliferated. All right. Anyway, these are the three categories of a data system. Application developers will primarily be interested in the resource data, the metadata, for being able to find the information that you want. And then, of course, once found, you're interested in the content data, which is getting access to the actual measurements and interpretations and models that you'll use for your workflow. As mentioned previously, content data is data that is produced and consumed in the course of normal business operations and would exist even without the data platform. Examples of this content data include sensor measurements, transactional data, interpretations, and models associated with any energy domain or function. The data definitions and representations for this content data are governed by the producing organization, whether this content is used during ingestion or created during enrichment and consumption. When possible, these data definitions reflect the needs and consensus of a community of users and are expressed by a formal or de facto standard. Resource data is frequently referred to as metadata within the OSDU forum. This data is created by the OSDU Data Platform to help describe, discover, manage, and deliver content data. There are two categories of properties in the resource data. The first are the system properties, which are consistent across all data definitions and used to support the data platform operations. System properties include elements such as unique identity, schema descriptions, versions, creation date, data lineage, and access control lists and entitlement tags. These system properties are defined and managed by the OSDU Forum's enterprise architecture community because they impact system-wide behavior. The second category is data content properties. Data content properties are properties that are used in the classification, description, discovery, and navigation of content data. Resource data content properties are specific to the domain and functions represented by the content data, and thus are usually derived from or governed by the same producing organization. In some cases, these resource data contain properties that simply expose information that's already available in the content data for the purpose of search. In other cases, the resource content data properties can provide additional information such as hints on data quality or originating organization. The OSDU Data Platform is designed to allow the registration of new content data types and representations at runtime. The structure of the resource data associated with all content data are registered through the schema service and captured in a system property called kind, which is short for a kind of data. Kinds have a four-part naming convention. The last element is the version number, since schemas and representations can evolve over time. The next element describes the type of data and can be composed of two parts. A group type that can be used in the classification of data, such as master data, reference data, or transactional data, and an individual type which relates to the business entity that is being described, such as well logs, seismic surveys, etc. The next element, definition authority-source, indicates the defining authority for the schema, which can either be the producing entity of the content or refer to a standards body if this is the source of the definition. The first element, namespace, recognizes that dialects and variations exist in the definition of data structures, even when defined by a standard. A common example is a number of variations of SegWi Rev1 data that exists, representing both the evolution of seismic acquisition and processing techniques over time, as well as reflecting nuances in acquisition and processing techniques by different service companies. Kinds support the principle of aligned autonomy. Autonomy is supported by the ability of anyone to register a new kind of data, whereas alignment is achieved by the support of well-known schemas, which are defined through a community or standards process. Well-known schemas are always preferable for collaboration since they support broad interoperability, and non-well-known schemas support the preservation of information from content sources, as well as the introduction and creation of new types of data. The OSDU Data Platform can be viewed as having three overlapping operating zones. The first, load and ingest, supports the definition, loading, and ingestion of external data into the data platform. The second, process and enrich, supports the discovery and improvement of data that already exists within the data platform. And the third, consume and deliver, supports the access to and export of content data in the platform according to the needs of the consumer. The green arrows indicate the cyclic nature of the data flow, with new data created by applications being re-ingested back into the platform to be discovered and reused by others. One of the system-imposed requirements for bringing data into the OSDU Data Platform is defining and honoring right of use. This is enforced as part of the governance function, where all the data are tagged with attributes that capture data ownership, data security, and information related to contractual obligations, data residency, and trade compliance. These legal tags, combined with contextual information about the user, location, and application, are used by the data platform when granting or blocking access to resource or content data. Ingestion is the act of bringing data into the platform. It can be implemented as either registering external content data by reference or directly adding content data by making a copy to the OSDU Data Platform. The preference will always be towards making a copy so that content data can be managed directly by the platform. However, there are cases when this is impractical. The ingestion process focuses on minimizing friction and maximizing the amount of information that is captured and preserved. The act of ingestion and the logical layer representing ingestion to the OSDU Data Platform should not be mistaken for a singular implementation. Ingestion is a contract with well-defined rules. Any entry of the data in the system should follow this contract, otherwise compliance and lineage cannot be ensured. Discovery is searching for data that has been ingested into the OSDU Data Platform. Discovery supports full-text search on string fields, range queries on date and numbers, and geospatial search, and is currently implemented using Elasticsearch. The data platform is implemented in a way that new search technologies and techniques can be implemented in the future, and there is ongoing discussion around the use of graph technologies. The resource metadata that is searched is created by indexing documents that contain structured or unstructured data. The indexer captures attributes defined in the data definitions for records created at the time of ingestion in the OSDU Data Platform. The goal is to have any attribute defined in the kind structure available for search. Enrichment is simply the act of creating new data from existing data. This can be as simple as normalizing coordinate and unit systems to support search, to something as complicated as creating new types by merging data from different data sources. In all cases, the new data is considered derived from existing data with lineage maintained between the derived data and its sources. Some of the examples of how enrichment is used within the OSDU Data Platform include normalizing units and coordinates to support search, creating higher quality records from multiple sources, optimizing data definitions and representations for consumption workflows, and fact extraction from documentation. Effectively, anything that processes data to create new data inside of the OSDU Data Platform is enrichment. The primary value of a data platform is realized at the time of consuming data. Almost everything mentioned prior to this, whether it's ingesting new data or enriching existing data, represents investment and cost for the purpose of making new data available and usable. Because consumption is so important, there are multiple consumption patterns supported by the data platform. These include content delivery from copied in or referenced files, the development of consumption zone, which are read-only zones for serving specific workflows, or what's called the DDMS, Domain Data Management Service, which is an optimized access for applications. I'll go into each of these separately. So delivering contents as files. OSDU resource and content data can be delivered as a set of packaged resources that can be exported from the data platform. This consumption model allows external systems to access data which they can then load by existing file import techniques. The advantages of this approach is that it's highly flexible and it allows the addition of new types without the need of introducing custom code that is type specific. This also caters to applications that are not directly integrated in the platform by providing a low-cost way of leveraging the data. The disadvantages of this approach are that applications will not be updated when new or rich data occurs, and frequently these applications are not obligated to bring data back into the platform. OSDU resource and content data can be consumed by way of read-only consumption zones. The data in this consumption zone is synchronized with the data platform and optimized for very specific purposes. The most common example of a consumption zone provided by the OSDU Data Platform is search. Indices are built from the metadata store and automatically updated as new data is ingested or existing data is enriched. The advantage of this approach is that it supports optimized, fit-for-purpose consumption of data in the platform, which is maintained by the platform itself so information is kept up to date. Disadvantages include data is often duplicated to achieve the fit-for-purpose, and the building of consumption zones can be somewhat complicated because it's very difficult to generalize a fit-for-purpose store. The third data delivery path is through Domain Data Management Services, also known as DDMSs. The OSDU Data Platform provides a set of data management service, representations, and APIs that are optimized for a specific domain and adheres to all the obligations of the OSDU Data Platform. These DDMSs are introduced into the platform to simplify the development of applications running against the platform and to improve the experience of the user in terms of capability, performance, and usability. Unlike consumption zones, the DDMS provides both read and write capability while honoring data obligations such as immutability, discovery, and entitlement. DDMSs can be complicated to develop and maintain, so they'll only be introduced with the data platform for domains that are relatively stable and where optimization are essential for platform adoption. Well-born seismic DDMSs are introduced with the Mercury release, and reservoir production and drilling are currently being developed. Now that we've covered the functional architecture of the OSDU Data Platform and you understand some of the major use cases that it supports, I'll now go into the services architecture, how they are built, and how they are mapping to the functions of the system. The OSDU Data Platform is based on a pure microservices architecture. These microservices have both common code to capture business logic and infrastructure-specific code to optimize performance, cost, and sustainability for different cloud environments. Within the OSDU Data Platform, service boundaries are defined by domain-driven design, and each service is developed, deployed, and versioned independently, allowing asynchronous delivery and evolution. Microservices in the OSDU Data Platform are built using the depicted design pattern. The services are based on common code that represents the functional behavior of the data platform that is identical across all cloud providers. The services define and expose a northbound API for use by application. These APIs ensure consistency in how services are exposed to applications to decouple the applications from service implementation and evolution. The services define and consume southbound service provider interfaces to simplify porting to multiple cloud providers. The services are then deployed on different cloud providers, leveraging the best technologies from a performance, reliability, and economic perspective that the infrastructure provider can offer. OSDU Data Platform services are developed and maintained in separate GitLab repositories under an Apache 2 license. The preferred repository structure is shown here using storage service as an example. Common code, unit test, API, and SPI definitions are maintained under the storage core folder. Platform-specific implementations are maintained under the provider folder. As shown, the storage service has been implemented on Amazon, Microsoft, Google, IBM, and MongoDB. You can find the API specification and tutorials under the docs folder, and finally, integration tests can be found in the testing folder. The OSDU Data Platform has adopted continuous delivery. A snapshot of the CI/CD pipeline for the storage service is shown here. There is a review process for code development that can be both manual for merge requests or automated, such as secrets detection in code. The build phase compiles all the common code and runs the unit test. Once successful, the compiled code is packaged and containerized for each of the target platforms. These containers and supporting source code are then scanned for quality, security, and policy violations. Assuming no fatal errors exist, the containers are then deployed to each of the cloud providers and integration tests are run. OSDU Data Platform services can be classified into two forms. There are core platform services to ensure the proper behavior of the OSDU platform and are independent of data type and thus can be used to support any data. They are relatively few and include support for things like security and compliance, resource data definition and storage, indexing and search, deployment and operations. There are also data-aware services that rely on the core platform services that expand as the data footprint of the OSDU platform grows and continuously developed and deployed against an installed OSDU data platform. They include helper services such as units and coordinates, data ingestion services, data enrichment services, and domain data management services. The data services can be further refined into two types. There are generic APIs that can be used to define and access any type of data. They are published as open endpoints to access metadata and data as generic types, allowing the continuous addition of new data types into the system. They are frequently used by system integrators and data managers because of their flexibility. There are also domain-optimized APIs, DDMSs, that provide domain-specific and optimized ways of accessing content in the data platform. They carry semantics not possible in a generic API, making them a powerful tool for application developers who want the very best performance and safety in accessing and creating OSDU data. Core services, generic and optimized data services, and external services all work together to deliver the OSDU data platform. The picture here attempts to map the services that an application developer will work with to the functional architecture of the OSDU data platform. You can see that the same core services are used to implement multiple functional requirements. An example is a dataset service, which is used during ingestion to capture content data, and then later to deliver in the delivery phase to deliver the same content data. Beneath the covers, the OSDU services also depend on each other. For an example, the indexer depends on the schema service to understand the properties of a record, And a storage service depends on legal and entitlement services to make sure access control through resource and content data is enforced. And I'll talk about how data flows through the OSDU Data Platform, giving you kind of a mapping between the data flows themselves and the services that they invoke. There are two dominant data capture and integration patterns for enterprise data platforms today. The first is an ETL model, where data is transformed outside the data platform to a canonical model for storage within the platform. Data is then exported for use by applications based upon this canonical model. This approach is intended to preserve the consistency of data within the platform. However, much useful knowledge is lost because the data analysis and transforms are performed outside the platform. The second is an ELT model, where data is loaded with no loss and then transformed within the platform to one or more target models. This approach was promoted and became popular with the development and adoption of data lakes. In the ELT model, data is preserved during ingestion and improvements to make the data usable are shared. The OSDU Data Platform supports both models, but its design and intended use were driven by the latter. This diagram provides a simplified view of the data lifecycle of data within the OSDU Data Platform. When bringing data into the system, the first thing you would do is you would define its schema or representation for the reference data. Next, you may invoke an ingestion workflow, which actually parses the data that comes into the system and extracts the metadata that you would like to store as part of the resources. When building up the resource records, you would invoke the entitlements and legal services to make sure that you have the right security model or access model defined for the data. Once these records have been created with the right access model and entitlements around them, the resource data would be stored in the storage service, and content data may be stored in a DDMS. The act of storing the data within DDMSs or the storage service will kick off an event that goes to the notification service. The indexer listens for those events, understanding that new content has entered the system. It would likely call the unit and CRS services to make sure that it creates normalized frame of references so the data can be searched. Users on the outside would then search the resource data using the search service and then eventually access the data either through the generic platform services or through a DDMS. As I've mentioned many times in the video, the OSDU Data Platform is developed in open source by a community. And this section talks a little bit about the community that's developing it. All right. The OSDU Data Platform is developed in open source in the community GitLab. All of the code that is contributed under the OSDU forum is licensed under an Apache 2 model, which is the most permissive license, open source license that we could find. And it has a policy which talks about dependent licenses as well. The purpose of its licensing is to make sure that the OSDU Data Platform is accessible and usable without restrictions. It is developed in the community GitLab. There's a link to the home project, which will be provided as a set of references, and it's developed as a set of microservices, as I showed earlier. And it is developed according to a PMC Project Management Committee governance model, which is modeled after the Apache Software Foundation model. So this is a model based upon meritocracy, where anybody can contribute, and your authority to contribute is based upon the quality and commitment to contribute that's out there. So again, it's open source. It's community developed. It follows well-established open source models for development and focuses on meritocracy as the model for gaining control and access. As I mentioned earlier, the technology for the OSDU Data Platform development began around 2015 inside of Schlumberger. And at the time of contribution, at the end of 2019, there were about 200 person years of development involved. These graphs talk about the sort of activity that is inside of the OSDU form itself. Roughly around the time of delivering R2 all the way through R3, and you can see that the focus in delivering R2 was pretty much on porting services and testing them for the platform. And then as we move between R2 and R3, or the Mercury release, we can see the community within the OSDU community GitLab growing significantly over time. Right. So this is the activity of developers. There are 200 and plus active developers out there, and you can see that at certain periods of time we had contributions of 50 people concurrently. And then in terms of code, the top graph is in terms of people. In terms of code, what you can see is that the code activity has grown as well. It's gotten quite healthy over time. Nice peaks in terms of commits, and our expectation is that if we draw the trend line out, hopefully it will continue to grow as more contributors come in and more code and other content is committed to the community. So this concludes the OSDU Data Platform overview, part of the application training. And what I'm going to do is I'm going to close on the training agenda itself so you can see what's next. This is the overall view of the application development training agenda. We began with the OSDU Data Platform overview, which is what I just presented. It's followed by a series of lectures covering the OSDU core platform APIs. A fair amount of time spent on the ingestion workflow because this is an area of high priority for new application development. And then it will get into the domain optimized APIs, the DDMS APIs. Following the lectures, there will be a series of labs. These labs are focused on the data lifecycle, so how the full lifecycle of bringing data, defining it, bringing it into the system, being able to search on it, being able to consume it again, primarily through the generic APIs, and it will be followed by 2 labs on the DDMSs, the first one on the wellbores and the second one on the seismic labs. So thank you, and I hope you enjoy the rest of the training.